Tonight, if the sky is clear, go outside and look up. You will see them right away. Hundreds of tiny points of light scattered across the dark. They look small. They look calm. They look like they have always been there, doing nothing in particular. Every one of them is a star. And not one of them is small, or calm, or doing nothing. A star is a giant ball of gas. There is no surface, no ground, nothing solid to stand on. It is gas at the top, gas in the middle, gas all the way down to the center. The closest star to us is the sun. We do not think of the sun as a star because we see it every day and it looks nothing like those little dots at night. But that is the only difference. The sun is a star seen up close. The stars at night are suns seen from impossibly far away. And here is something most people never realize. The sun is not a special star. It is an ordinary one, an average one. Many of those faint little dots you can barely see are far larger than the sun and far more violent. They look faint only because they are further away. Distance shrinks them. It does not make them small. So here's the real question. We see stars our whole lives. What makes them shine? The answer is inside the star, in its center, and it starts with something simple: weight. A star is an enormous amount of gas, and all that gas has weight. When that much material is gathered into one place, every part of it is pulled inward, toward the center. That pull is gravity, the same force that keeps you on the ground. The outer layers press down on the layers beneath them. Those layers press down harder on the layers below. It builds and builds all the way down until the center of the star is crushed under a weight almost impossible to picture. And when you squeeze something that hard, it gets hot. The core of the sun sits at around 15 million degrees. At that temperature, under that pressure, the gas in the core stops behaving like normal gas. It is crushed so hard that it begins to turn a tiny part of itself directly into energy. That is what makes a star shine. Deep in the core, the star turns a small amount of its own material into pure energy. And that energy is enormous. It pushes out from the core, climbs up through the layers of the star, and finally escapes from the surface as light. That light crosses space, and a small part of it, after a long journey, lands in your eyes when you look up. A star can keep shining like this for billions of years because it only converts a tiny part of itself at a time, and there is an enormous amount of it. So that is why a star shines. Now look closer, because the stars are about to tell you more than you expect. Ask most people what color a star is, and they will say white. But stars are not white. Go outside on a clear night, away from city lights, and really look. Some stars are blue-white, some look yellow, some are orange, some have a clear, deep red to them. The color is not random. The color of a star tells you how hot it is, and the order is the opposite of what you might guess. We tend to think of red as the hottest thing, but for stars, it is reversed. A red star is the coolest kind. An orange star is hotter. A yellow star is hotter still. And a blue-white star is the hottest of them all. Our sun is a yellow star, which means, once again, it sits right in the middle. Average temperature, average color, an ordinary star, exactly as before. So when you look up and notice that the stars are not all the same color, you are not seeing decoration. You are reading their temperature straight from the sky. There is one more thing the sky is hiding, and it is about brightness. Some stars blaze, others are so faint you can barely catch them, and it is natural to assume the bright ones are the big important stars, and the faint ones are the small ones. But brightness can fool you. A star can look bright for two completely different reasons. It might be bright because it is genuinely close to us, or it might be bright because it is far larger and far more powerful than the sun, shining at us from a great distance, and it works the other way too. A faint little dot might be a small, dim star nearby, or it might be a giant, so far away that all its power shrinks down to a speck. Just by looking up, you cannot tell the difference. Two stars sitting side by side in the night sky might be nothing alike. One could be a close, modest star. The other could be a giant hundreds of times further away. Your eyes cannot separate the two. Brightness in the sky is a mix of how powerful a star truly is and how close it happens to be. Which brings us to size. And size is where stars stop making sense. Start with the sun, because the sun already feels impossibly large. More than 1 million Earths could fit inside it. That is our average ordinary star. Now, make it bigger. The largest stars we know of are so enormous that the comparison stops working. If you removed the sun and dropped one of these giants in its place, it would not just be bigger. It would swallow the space where Earth orbits. The Earth would no longer be circling the star. The Earth would be deep inside it. That is a real kind of star. And some of those quiet little dots in the night sky belong to stars like that. They look tiny only because they are so far away that their enormous size collapses into a single point of light. So now you know what you are looking at. Giant balls of gas, turning themselves into light, shining in colors that reveal their heat, sizes the mind cannot really hold. There's just one last thing to explain. When you watch the stars, they seem to flicker, to shimmer, to twinkle. And after everything we have said, you might think that Twinkle is the star itself, something happening out there in space. It is not. The star is not flickering at all. The light from a star travels across space perfectly steady, calm, unchanging. It crosses an enormous distance without a single flicker, and then, in the very last moment of its journey, it hits the air above your head. Earth's atmosphere is always moving. Warm air, cool air, pockets of gas shifting and sliding over each other. And when that steady starlight passes through all that moving air, it gets bent. Slightly this way, slightly that way, again and again, in the final fraction of a second before it reaches your eye. That bending is the twinkle. It does not happen at the star. It happens here, just above you. The twinkle is not something the star is doing. It is something our sky is doing. And there is a way to prove it to yourself. The next clear night, look for a light that shines steadily, calmly, without that flicker. If you find one, you are very likely not looking at a star at all. You are looking at a planet. Planets do not twinkle the way stars do, and now you know enough to tell them apart with your own eyes. So tonight, when you look up, you will not just see dots anymore. You will see giant balls of gas turning themselves into light. You will see their heat written in their color. You will see size you cannot truly picture, shrunk down by distance into something small and quiet. And you will know that the twinkle was never theirs. It was always ours.